we want to graph this right here. So if you're going to graph that, the slope, start out with the slope for this one. Slope is -4 over 1. That means down 4, right 1. Okay, your starting point is here. That's called the y-intercept. It's your first dot. So when you go to your graph, it's the green line. I put your first dot right here at 3. It's between 2. They're counting by 2, 4, so 3 is there, and you go down 4. So what I do is I go, okay, I go, here's halfway, that's 1. Well, let me show it another color. Here's halfway, that's 1. And here's another way, that's 2. And then I go over 1, and then there's my dot right there. That's the green dot you got. Okay, I'll do it in blue. But anyways, and you keep going like that. You go 1, 2 over 1. 1, 2 over 1. 1 halfway, 2 over 1. That's what I did. And the same thing, on the other one, if you're going to graph, okay, the red one, the y-intercept is at 3 also. This is 3. Your slope is 1 over 4. That means you go up 1, right 4. You start at 3 on the y. So you find 3 on the y, which there, up 1. So I went up 1, right there, and over 4. 1, 2, 3, 4. There you go. And I ran out of room, or I can go up 1, 1, 2, 3, 4, right there. Continue like that. Goes my line. Oh. Right there. Okay? And where does the point intersect? At 0, 3, right there. What does the point of intersection represent? The only point where the coordinate works for both equation, or which is called the solution. The only point where the coordinates work for both solution, for both equation, it is this 0, 3 is the solution. Okay, now I'm going to have you explain why on your test. Why is it called a solution? Show the work for it, because it's the only ordered pair that works for both, that gives the exact same. That 3 equals to 3. Okay, that works. Compare the slope. The slope is 4 and 1 over -4. They are opposite and reciprocal of each other. That makes it perpendicular. So the graph should be 90 degrees. Look, it's perfect 90 degrees. You don't even have to guess. No matter where you're at, it's 90 degrees. Okay? Because it's opposite and reciprocal. Are the lines in question 2 perpendicular? Yes. The slope are opposite and explain your reciprocal. Therefore, the lines are perpendicular. Perpendicular. Or what it is, it makes 90 degrees. Does the graph appear perpendicular? Why, yes, because it creates 90 degrees. Okay? Now next page, we do this. Now Eric's sister. Eric was what? Eric was $25 plus 25x, right? Yeah, that's Eric's. His sister, Trish, was able to save $500 working part-time, during the first semester. She recently quit her part-time job to play softball. Okay, whatever. She is hoping to get a college scholarship to play softball and wants to devote her time in achieving her goal. She withdrew. This word withdrew is a minus. $25 per week. X, remember, represents week. From her savings account for the spending money while she's not working. Write an equation that gives the total amount of money that Tish is saving in the Tish saving amount. So this is total amount of money in Tish savings account. That Y equals for Y. In terms of numbers of weeks for X. Okay, so we got that. We minus because it's a withdrew. And then write a system of equations. That means write the two equations together. Okay? And then let's graph it. For me, I didn't need the table because these are beautiful numbers. Slope of 25 and negative 25. This means you go up 25 and over right 1. Okay? And the slope of negative 25 means you go down 25 and you go right 1. Okay? And you graph. And I counted each block by 25, but the tallies were 50s. Okay, and that's what we did. And we got that. And that's Eric, and that's his sister Trish. See, the line is going down because she's spending all her money. At the very bottom, all her money is gone at $0. Well, Eric's saving it. Okay. So his saving account keeps going up. What does the point of intersection represent? It represents the number it takes to have the same amount of money, number of weeks it takes to have the same amount of money in the bank for Eric and Trish, his sister. Compare the slopes. Eric's slope is going up $25 for each week. Tish's slope is going down $25 for each week. You need to put that. Okay? Are the line perpendicular? No, because it's not 90 degrees and the slope is not reciprocal. They're just opposite. It looks close to 90 degrees, but not quite. Okay, and then the last page, you need to answer if it's parallel, perpendicular, or neither, and explain. First one is perpendicular because the slope of 3, 4, and the negative 5 over 4 are opposite. And it's very important you say this, and reciprocal. Neither, because the slope are not the same or opposite. They're reciprocal, but not opposite. It needs to be opposite to be perpendicular, and it needs to be the same for parallel. Okay. Parallel because the slope of negative 2.3 and negative 2.5 are the same. So these slopes right here are the same. These are neither, because the slope of 5 and negative 5 are not opposite. Also, they're reciprocal, but they also need to be opposite. Well, opposite. Oh my gosh. Oh my, opposite. Right? Anyways, you guys know what I mean. They need to be both opposite and reciprocal to be perpendicular. So this is your